Good afternoon to everyone. This is Dr. B. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical Engineering, Hyderabad. So myself, really today I'm very happy to deliver my video lecture on image segmentation in color image processing. So what is this image segmentation in color image processing? How we are supposed to be understand such a concept is one of the topic from our syllabus, which is image processing. There, the topic which we are completely connected towards to understand this image segmentation to especially to the industrial applications. So you are all so you have to concentrate how this image segmentation concept will help us to prove itself. That means to get some proof of the concept. So one of the opportunity to us towards to have the knowledge on the connection of proof of the concept is this topic only. So what is that topic name? I will repeat boldly: image segmentation in color image processing. So this image segmentation in color image processing, how we can able to deliver in the sense you are supposed to be understand by taking an image, okay. So this may be a 2D image or a 3D image, okay. So such a image, whatever may be the dimensional image, this dimensional image, you are going to be concentrate, not be what we called not be fixed at one instant of variation of the your parts of image values. Value in the sense pixel values. Pixel values in the sense the intensity of the pixel, how it can be various. So how can you make concentrate is here? Let us we apply that. The meaning of image segmentation is a process of assigning a label to every pixel in an image such that pixels with the same label share certain visual characteristics. Sometimes it becomes necessary to calculate the total number of colors from the given RGB image to quantize the image to detect especially your quantized cancer values are from the brain tumor. So what you want to understand is here you are supposed to be understand the image segmentation is a process of assigning a label to every pixel in an image such that pixel with the same label share certain visual characteristics from the your selected image of detected values. What is that your selected values is? Your selected image is brain tumor image. Maybe it considered as an MRI image. So such a MRI image which you are concentrating here in aspect of detecting the cancer issues. Okay, so how you may want to concentrate this? Let you see this this image segmentation in color image processing. How you are going to be concentrating is it is the process of dividing an image into its constituent parts or objects. Common techniques include edge detection, boundary detection, threshold based detection, region based segmentation, nothing but region based detection, among others. Among others, in the sense, you consider your what we call your image of the pixel values. So pixels values are compared with the neighborhood values. So that means to focus on segmenting our image using color image segmentation through HSV color space, which is one of the color model. We earlier we discussed that there are three types of color models. One is RGB based color model, second one is CMY, and third one is this HSV color space model. Okay, so how this type of HSV color space model we may be developed in the sense, let we take one image. Let us assume one of the image which is in terms of color, especially you are applying here segmentation segmentation to the your image. How you are applying here segmentation to the image? You are considered as an image which is a completely one image which contains so maybe different colors of the parts, so like RGB, red, green, blue. So we can find out here red, green, blue, and yellow also. So what do you mean to understand from this image? So a image which contains the parts of the colors help us to understand the definition of your segmentation. That means image segmentation in color image processing is the best example of this image, which shows us one under one label you are divided into subparts of the colors for understanding towards to compare one color with the other within the same label of the image. So such a process is called image segmentation. Because we are concentrating here in terms of color image processing, that's what we say. This image segmentation is in color image processing. Of course, you got it my point from this explanation of the image. Okay. Next, coming to the such a image which you got understandable, then from there you are concentrating to find out certain values of information. What is the value of information you want to say? You are going to be parts divided into your required parts on x-axis versus y-axis. What it helps us x versus y-axis towards to define one objective function. What do we call one objective function? What do you mean one objective function? The objective function which help us as a f of x comma y is a finding the different objects from the image. So that is the what we want to concentrate here. So with respect to x and y, we want to calculate the value of the image. So that means you are supposed to be concentrate such image values in terms of saturation, means you are going to be find out nothing is here. Saturation is nothing here. You are going to be concentrating here such image processing which we want to concentrate one to other is also impossible. But there we keep in terms of objective function which help us towards to has the relationship in between x and y, so that x and y, x to y or y to x values how it may be varies one to other, in the sense you are going to be concentrate for the help for the sake of development of your image segmentation based on the selected objectives. So coming to the such a image segmentation in color image processing is right now you are going to be concentrated here is HSV channel of color image, that is HSV channel of color image in color bar format. So you are taking format. This is bar format. What we call this one is color format. Bar format. You are going to be understand from this bar with the help of RGB color. Understand? RGB color. Okay. So such a frequency variation of the values based image which we are keeping here in terms of your concentrated blue color or so which we are concentrating is here the transparency of the color which we are going to be concentrate in terms of divided according to the your model channel is here. So coming to the major process of this image segmentation in color image processing, your major advantage is that the model fact that is presents a immunity to illumination changes, since the illumination is enclosed in the lightness component of the model. Here model is HSV model, HSV channel model. So that help us, that model can be found in color hues changes, their continuous and linear effects we may find out. Okay. So, for example, let me take that findouts of HSV channel by the help of image segmentation. We apply to certain application in aspect of enhancement, and simultaneously you are concentrating the segmentation. So that example is here. You take the one different segmentation technique that gives here results in the format of pictorial representation form. So let you take your MRI image, which is brain tumor. You are concentrating is brain tumor. I'm using this image segmentation process towards to find out this tumor from the brain. How you are finding in aspect of size of the tumor? Is there any affection of the such a tumor in the brain? If it affects, how it may be affect towards to understandable in terms of determination of any cancer. If it's there in the cancer stage, is there aligned? Is there malignant stages, or it is a normal stages? What are the stages? So such a stages of finding, basically a physician can concentrate here. But you being an image processing engineer, you are preparing such a HSV model based on the image segmentation process. It such a model helps to the physician in terms of assistant to the physician, assistant to the such a doctor. So the doctor is easy to understand what is the size of the tumor in the brain. Is there that tumor brain change tumor is affecting the brain in aspect of cancer process, or any other aspect that in the sense which we may help to the patient. So, in the relationship of patient and a doctor, your prepared model will help to them. So that's what this image segmentation in color image processing is the more one of the important concept, most important. Let you take that parametric deformation model, which also compares here in terms of provides exact region of tumor compared to all the algorithms. What are the algorithms we are comparing with image segmentation, or image segmentation based? You are applying K means cluster algorithm, image segmentation based fuzzy C means, image segmentation based fast boundary box algorithm, image segmentation based sneaks algorithm we are applying. So once we understand this image segmentation process, depending upon your selected label, nothing but image, then we can apply such a pixel relation values of the label in aspect of image segmentation. That segmentation based, we prepare the algorithm. That algorithm completely, which help us in terms of your required justifications, your required parts of image processing. So that is what we can understand from this slide. So I'm continuing that proposed enhancement and segmentation process is here. Compared with the segmentation, we are also going to concentrate gamma corrections. So what is this skull remove based on segmentation is simply we can understand in aspect of superpixel segmentation process. So superpixel segmentation is process happen in especially in the aspect of color image processing. So that we are going to see in later from the coming slides. So that means you are supposed to be understand enhancement is here happen in aspect of contrast of the your selected image, nothing but input image, and then you are going to be used as a gamma correction. So what you can say that enhancement is the operational process in aspect of increase the contrast of the image, input image, and it is called gamma correction. So superpixel segmentation, that is SLIC segmentation, is completely by separating the image into numerous group of pixels. That is SLIC is a clustering algorithm compared with of k means for the correction of the superpixels. So this process will help in aspect of comparison. How your comparison with the segmentation model. How your concept with your topic. Your topic is here image segmentation. Image segmentation. So that you are going to be understanding. So coming to the extensionally, we can concentrate this enhancement and segmentation in aspect of optimal threshold based, region based, pseudo color conversion based. So such a colors we can also help us to define one deep learning technique. So that deep learning technique model, which is your compare with your HSV channel model. HSV channel model. So for that, I'm discussing is here. For that, I'm discussing is here that let me to say optimal threshold means the threshold is effective segmentation of images and use the variance and mean as the primary metrics. Whereas region mapping based enhancement happen, that is region mapping is the step of operations which eradicate incorrect boundaries and bogus regions by merging adjacent regions based on the gray level or gray value of these regions. So region mapping is accomplished to group the tumor regions detected together as a single layer of region after thresholding. So where we compared this optimal thresholding and region mapping to the pseudo color conversion is that after the segmentation, the image will gray here recreated the segment image to the label RGB. RGB means color as pseudo color image processing. So with the help of this, we are applying to the extensional model. That model is here one of the deep learning technique. That is called here ICCAN model. AN model. Of course, it is not the part of syllabus, but for the sake of understanding certain examples and application, I have thought the same. So coming to the, if at all you are using segmentation, how that segmentation is concentrating, which you are concentrating as a brain tumor image. So MRI image is here, we are taking, and you are concentrating that a tumor part is here. That tumor part, how it is affected, the remaining parts you are going to be check one by other. So that size based part by part, how you may be happen in this, it is happen based on the segmentation only, based on the segmentation process only. That is the only happen segmentation processes. So then only you find the what is this size color of the that size particular size. You see different colors are here. So that means the results is of your concentrating segmentation results from the original image by obtaining your one another of your selected parts of concepts in aspect of optimal thresholding, region mapping based only. So if your selected image is MRI image as affected, that is malignant stage cancer based input image you are taking, and that you are going to be see the enhancement segment based and pseudo color, which we are going to be concerned your tumor alone. So this is what we want to understand, how your segmentation help us to define towards to concentrate the model which you are prepared, being an technocrat, you are preparing such a model towards to help to the doctor as well as patients. With this, I'm closing my discussion, that is ELRV today topic, that is say image segmentation in color image processing, is also help us towards to refer some list of references. As per our syllabus, prescribed textbooks are here too. One is you are going to be understand from the digital image processing subject, so you can refer all the concepts whichever we are discussing today also. So with this, I'm very happy to say very thankful to you all for your patient listen, and this segmentation, this image segmentation topic will definitely help you towards to apply it to the various application. I was concentrate one of the application is here is medical image processing. There, that medical image processing based on our discussed concept will going to be help towards to assistant to the that model is assistant to the physician. That physician will easy to deliver, easy to help to the patients. So our concepts are not that much what we called negligible. It is very important. So once again, I am very thankful for your kindly listen, including this summary discussion also. Thank you so much. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.